Hello, and welcome to 5 Minute Math. My name is Aaron Daffer, and I am walking through the fifth grade mathematics STAAR test from 2024, item by item. If you want to look at how each item performed across the state of Texas, I created a custom item analysis report you can get using the QR code you see on the screen or the tiny URL. And if you want to jump to a specific problem, you can use so using any of these timestamps or the bookmarks at the bottom of the video. For number one, we are solving data problems. This is standard 5.9C, and we have the number of visitors at a park recorded for 5 days. You notice we're missing Wednesday, and it simply says the number of visitors on Wednesday was half the number of visitors on Friday. So Wednesday equals 1/2 Friday. All right, so Friday is not even that difficult. Look, Friday is right there right at 400. It's not even in between 400 and 450 or anything. So Wednesday equals 1/2 of Friday is 400. So let's just make 400. So half of 400 is 200. And you notice that is our first answer there. And that's it. I mean, that's our answer there of A. And I'm glad that we started out on this one because we had 86% of our students in Texas get this one correct. We had 9%. This is just kind of statistical noise. 9% and then 3%. So those that got tripped up by B and C, right? This 175 is the halfway point between Tuesday and Thursday. So they were just taking a look at this one, taking a look at this one and trying to find the halfway point. That's a weird way to do it. So they didn't necessarily read this. And then your 800 is you took your 400 instead of half, you just multiplied it by 2. So there's ways to get there. But this is the first easiest problem. So I'm going to rank all of these problems in regards to how difficult or easy they are. This is the easiest problem on the entire test. So this was a great one to get started with. And obviously, as we keep going, they will get a little bit more difficult. For number two, we are dividing with two-digit divisors. And so we've got a farmer here, and our standard is 5.3C, and this farmer has 1850 broccoli seeds and exactly 40 seeds in each row. Okay, so what we have here is this is a part whole problem, right? So my total is 1850, and then I need 40 seeds in each row. Okay, so I've got seeds, rows of 40, and I don't know how many rows of 40 it takes to get it all the way up to 1850. So what is the greatest number of complete rows? So there might be a remainder I need to interpret. Okay, so let's just think. 40 goes into 1850. And honestly, if I want to make this a little bit easier, right, I could divide both by 10. If I divide both by 10, I shift them over on the place value chart, and I can just think 185 divided by 4. So if you wanted to do that, that would also get you the same answer. So 40 goes into 18 0 times, but 185, I've got 4 times 4 is 160. So that's going to give me that right there. So that's 160. Then I've got 250. So that's going to give me 6. 240. You notice I've got 10 left over. I don't need that. So I've got 10 out of 40ths left over, or 1/4 left over, but I need complete rows of broccoli. So the complete rows of broccoli is going to be this D46, and that is going to be our correct answer. We had 67%, so still pretty good. Anytime we can get above 60%, we're feeling pretty good about this problem. We had A was our most chosen incomplete answer, or incorrect answer, 16%, and you can guess why, right? There's a little bit left over. 46 includes the remainder and just kind of rounds up. And so that was our most chosen incorrect answer. Then we had 9% and we had 8%. So these two they made mistakes with the standard algorithm. So we need some We need some practice with the standard algorithm, and honestly, by the time we're in fifth grade, our students need to work problems not just with two-digit division, but also interpreting the remainder, which is actually a fourth grade standard, but that is something that can be carried up into fifth grade, where they're given these real-world situations and they need to interpret the remainder, either include it, don't include it, identify just the remainder itself, do something with the remainder to give our students more practice. And this is tied for our eighth easiest problem. So like I said, 67% is not too bad. We're feeling pretty good about this using the data from the state of Texas. For number 3, we're looking at area, perimeter, and or volume. This is standard 5.4H. The standard includes all of those, so you never really know what you're going to get there. So this is a multiple select. We need to select 2 correct answers. Let's go ahead and shift this down. We need a rectangular prisms with volume of 24 cubic centimeters. All right, so I'm just going to put V equals 24 centimeters. That little 3 means cubed. All right, so remember our volume, if we get stuck, is going to be right here. Volume is going to be length times width times height, or base times height. It looks like they're giving us 3 dimensions, so we can do length times width times height. So let's say volume equals length times width times height. Sometimes we can use base times height, and that's probably the more common one you're going to see moving beyond elementary school. Base times height, but we can do length times width times height. We're just looking at 24. So 4 times 2 times 3. That's literally what we're doing here. So 4 times 2 is 8. 8 times 3 equals 24. So that one is good to go. We're going to select that one. Let's keep going. Look at this. 8 times 8 times 8. That is going to be 64 times 8, and that is going to be 512. So you see what they did here, right? 8 plus 8 gets you 24. So that's the kind of confusion there. I've got 8, 10, and 6 down there at the bottom. So let's see, 8 times 10 times 6. Same thing. If I were to add these, I'm going to get 24. If I multiply them, I'm going to get 80 times 6 equals 480. So these two include addition, right? Let's do 6 times 2 times 2. 6 times 2 is 12. Times 2 equals 24. So that's good, which means this one must be wrong. And guess what this is going to do? 9 times 5 times 10. But look, 9 plus 5 plus 10 gets you the 24. So this is 45 times 10 equals 450. So the 3 incorrect answers all added to 24. So this had a percent correct of some different levels here. 2 points, 1 point, or 0 points. 77% of our students, 77% got both of those correct. That's fantastic. 6% got 1 correct. So what we do is we take half of that, that's 3, add it to the full point, and we say overall we had 80% correct on this. And we did have 17% get 0 correct, but remember, 80% is fantastic. So this is our second easiest. So we have started with some really easy items on this fifth grade STAAR test, but it is about to get a little bit more difficult. For number 4, we are looking at simplifying expressions and using the order of operations. So this is standard 5.4F. Now what's interesting is, take a look at this. An expression is shown, but we need to find an equivalent expression. We're not simplifying all the way down. We're just going to simplify. Let's just do one level at a time. So we don't even need to get all the way down. We could check our answer that way. But if I were to do this, right, 6 bracket 2 plus parentheses 1.7 times 2.3 plus 39. I need to remember my PEMDAS. Please excuse my dear Aunt Sally. putting the multiplication and division together because they can be either one. I don't have any exponents, but I do have two sets of parentheses. Okay, so first we've got this bracket. So the brackets come first. So you have to do whatever's inside the bracket. And then the parentheses inside comes second. So what's inside the bracket? So let's just focus in on the bracket. In the bracket, I've got 2 plus 1.7 times 2.3. Well, what am I going to, if I apply the order of operations to just what's in that bracket, it's like an equation within an equation or an expression within an expression. I've got parentheses that I need to do. So the first thing I need to do is this right here. 1.7 times 2.3. So now I've got decimal multiplication here. All right, so I'm going to ignore those decimals. Just going to bring it back in at the end. So that's 21. That's going to be 3, that's 5. And that's going to be 14. And that is going to be 2 and then 3. So I've got 391, 2 digits behind the decimal, 2 digits behind the decimal. So 3.91. So what I could do is I can rewrite this entire thing here, and I could say 6 bracket 2 plus, and then what I'm going to do is I'm just going to replace 3.91 plus 39. So this was the first thing I needed to do. And then I would take care of the brackets. I would add those, then I'd multiply by 6, then I'd add 39. But this is as far as we need to go. You see we've got our answer here at A. So that's as far as we need to go, is we don't simplify it all the way. All we need to do is just to figure out which is an equivalent expression, right? So we had 49, only 49% of our students get this one correct. So this was definitely more difficult. We had 26% of our students choose B, the incorrect answer. What do we do here? Well, we just solved left to right. They ignored this bracket, and they did 6 times 2 equals 12, and then they just went about their day. So 26% of our students, they might have known parentheses, but they didn't know what to do with that bracket, so they just ignored it and moved on. We had 11% of our students choose C, and so this one is kind of random. We just kind of solve from right to left, right? So they did 39 plus 2.3, and you're going to get that 41.3, and then you just multiply by everything else. It's kind of weird to look at it that way, but yet 11% of our students think that was the best answer, and then 14% of our students chose D. So they did this first. They did the 2 plus 1.7. They just ignored the parentheses, but they knew that something had to happen within that bracket. So they ignored the parentheses and they did the 2 plus 1.7 equals 3.7. So this was definitely more difficult. This was actually tied for our 10th most difficult or 10th hardest question. And so we need to give our students opportunities to not only work with simplifying expressions or order of operations, but this was a new way to ask it. Don't even simplify it all the way down. Simply find an equivalent expression with one, possibly two steps in. So that's going to be a new challenge, a new way for our students to look at this. Is not simplifying all the way, but simplifying with one or two steps, and that will help give them practice as they are learning this skill. So next, we are representing equations for multi-step operations. This is 5.4b. And what we have is we've got Jeremy. Jeremy's got a string, 84 inches long. He cuts 4 pieces from the string that are each 18 inches long. Okay, so first, it looks like this is a part-whole problem, so I'm just going to draw my total. 84 inches. Okay, he cuts 4 pieces of string that are each 18 inches long. All right, so what I'm going to do is I'm just going to put 4 18s here. There we go, 18, 18, 18. Might not be proportional. And then which equation can be used to find z, the length of the leftover string. Okay, so leftover string. Well, let's see. Leftover string means it's going to be this z right here. Because let's figure this out. What is 18 times 4? 18 times 4, okay, 72. Which means if he is going to cut 4 pieces of string that are each 18 inches long, he didn't use the whole string, because 72 is less than 84. So how do we represent what I just drew with equations? Well, let's see. If I wanted to get the total of 84, and you notice what I'm doing here, right? I'm either multiplying by 4, and then I've got my 4 operations down here. Well, how did I get 72? I multiplied. So I'm going to multiply 18 times 4. Now, A and C are the two most chosen answers. I also could have done D, but no one really thought division was a decent answer. Actually, that was the third most, but it's going to be not as impactful as A or C, because what are we doing with this Z? Am I subtracting it? Am I adding it? Or am I dividing it? Well, if I wanted to get to 84, what would I do? I would do 18 times 4, but this is a part whole. I would need to add that Z, which means my answer here is going to be C. Now, this is tricky because that is our correct answer. We only had 32% of our students get this correct. 32. And more than that, we actually had 35% choose A. So more students chose the incorrect answer of A than the correct answer of C. And then if you're looking at D, not as popular, but I mean, honestly, 26 isn't that far behind. 26%, only 7% here. So what was so enticing about A? They knew it was 4 pieces, 18 inches each. Okay, that's multiplication. And it's this leftover string. They thought that leftover meant subtraction. Okay, and so this is where we need to provide our students opportunities to not just read the problem, but they need to be drawing pictures. Because if we can first translate this into a strip diagram, they would see that to get my total of 84, I'd have to add in the z. But if I'm just trying to solve this problem without drawing a representation, I can see that subtraction might make sense with leftover. Not really so much division, we're just guessing. But we need to draw a picture. This is tied for our third most difficult item on the test. Only 32% got it correct, and more students chose the incorrect answer of A than chose the correct answer of C. Next, we are comparing and ordering decimals. This is 5.2b. And so we just got this list of numbers here, and we need to list it from least to greatest. Okay, so there's horizontal. That's not going to help us. Let me line them up. Okay, so I'm going to draw a place value chart. So I've got my ones. Okay, and so I'm just going to put the value there. I've got my tenths. And I've got my hundredths. 0.01, and I've got my thousandths, 0.001. All right, so let's put them in here. 4.76, 4 and 76 hundredths, 4.8, 4 and 8 tenths, 4.753, 4 and 753 thousandths, and 4.801, or 4 and 801 thousandths. Well, when we line it up like this, let's add zeros. When we add zeros, it all makes sense. Look at my first digit, 4444, which they're all the same, which means what I'm evaluating is this 760, 800, 753, 801. If I can just evaluate those sets of 3 digits, that's so much easier. Least to greatest. What's my smallest is going to be this 4.753, 4 and 753 thousandths is first. Now I've got my 4.76. I'm just going to write the 4.76 rather than 4 and 760 thousandths. And then look at this. My 4.8 is smaller than my 4.801 because it's 4 and 800 thousandths as compared to 4 and 801 thousandths. So there's my list from least to greatest. Goes like this. And third, 4.8. So my answer here is B. Now, across the state of Texas, not too horrible. We had 61% of our students able to get this. Had to do quite a bit of work, but they were able to get this. And we had 18%, right, choose A. So that was our most chosen incorrect answer, though C was not too far behind. So at this point, we're just kind of guessing. But if you chose A, guess what happens? You could do all this work, and if you list it from least to greatest, instead of if you list it from greatest to least rather than least to greatest, right? So if you go from greatest to least, that's first, that's second, that is the third one. So we might have had some students do all of this work correctly, and they just listed from greatest to least rather than from least to greatest. Now, this one right here, if you chose this one, you're probably listing from least to greatest, but they were just looking at these digits, 8, and then 76, and then 753, and then 801. They weren't even looking at place value. They were just looking at the digits after the 4, and this one is third. So that is a huge misconception. If we have students doing that, then we probably need to spend some time with our place value chart and making sure we're adding zeros so that our students have every opportunity to line up the numbers and get these correct. For number 7, we are classifying two-dimensional shapes. You see we have a triangle here. This is standard 5.5a. And what we're trying to do is we're simply trying to classify this triangle using this chart. And is this an acute triangle, equal angular, obtuse, or right? And so here's what we need to do. We need to know the definition of each of these types of triangles, and none of these definitions are going to be on our mathematics chart. So we need to go into the STAAR test knowing this. So an acute triangle has 3 acute angles. Now we'll talk about what these angles are in just a moment, but let's just go through definitions. Equal angular is a term we don't use too much. Normally we'll use equilateral, but it gives you the same idea, that equa meaning equal, right? So 3 equal angles. So that's a special type of acute triangle. Obtuse has 1 obtuse angle, and then the other 2 are acute. And then the right is the same thing, 1 right. The problem with those two, right and obtuse, is if one of them is right or obtuse, the other 2 have to be acute, just because those angles are so long. There's only 180 degrees in each triangle. So our benchmark is always going to be, and I'll use the connect line feature, is a right angle. So that's what we visually teach our students. We've got this right angle, 90 degrees. So that's a right angle. So an obtuse angle then is going to be anything that is larger than 90 degrees. So here's an example. And so let me just kind of, let's go back to draw here. So obtuse is greater than 90 degrees. And then I've got, let's do magenta, and acute is going to be less than 90 degrees. So those are going to be our benchmarks here. And so take a look at this. Y definitely looks acute because I would say a right angle is right here. So that's less than that, so that's acute. And then Z also, if that's my right angle, that's less, that's also acute. So 2 out of your 3 are acute. Take a look at this X. Now this X is a little bit difficult because it's not necessarily horizontal, but if I were to draw a right angle from this x. I'm thinking it would be something like right here. Like that. I'm trying to make a square corner out of this side right here, and it looks like it's going to be somewhere around there. So it's larger, which means this is an obtuse triangle. So this is an obtuse triangle. This means this is an obtuse angle makes it an obtuse triangle. Because once one angle is classified as obtuse, that makes the whole triangle an obtuse triangle. This was a difficult problem. We had 45% of our students classify this as acute. They might not have known exactly what it meant, but these two angles are definitely acute. So they figured 2 out of 3 wasn't that bad. We had 9% choose equiangular. Once again, that's a phrase we don't use very often. We had 41%. So this is less. Get the correct answer of obtuse. So more students chose acute than chose obtuse, and then not many students chose right. So I think we know that. So that's the good news, 5%. We know what a right angle is, but obviously we need to spend a little bit of extra time looking at the difference between acute angles and obtuse angles, and then how those acute angles and obtuse angles help classify obtuse triangles and acute triangles. For number 8, we are dividing unit fractions and whole numbers with models. And so this is standard 5.3J. And this is sometimes a confusing standard for students. You see we have a drag and drop. So Sarah's got 1/5 of a cake. All right, so let's just, right here, I'm going to use my red to draw my fifth. So I've got this dotted line. What they'll do is they'll draw an original fraction, and then they're going to cut that fraction. So there's my 1/5 right there. See, I've got my 1/5. I'm just going to draw 1/5 on each of these. We're ignoring the horizontal dashed line. Okay, she shares a fraction of the cake equally with her friend. Okay, so that's where this comes in. So now she's going to cut it in friend. So I'll say her, and then I'll say this other one here is her friend. Now, what equation represents this situation here? Well, let's look to see how much each of these pieces are. Okay, so originally we had 1/5, so we can start with that. We had 1/5, and then what did we do? We shared it equally. Okay, so we divided it. You notice how we cut it in half there? So we divided it in half, or cut it in half. But when we're cutting it in half, really what we're doing is we're dividing it into 2 equal parts, and that's where it gets tricky, because it does look like 1/2 could be there. But we're taking each fifth, we're dividing it into 2 equal parts, which sometimes we'll call cutting in half, but we don't want to necessarily use that half. We could use that half if we had a multiply. So if we cut it in half, that's actually multiplying by 1/2, but we don't have the multiplication option. We only have the division option. We need to divide it by 2. So what does each friend get? Well, each friend is going to get 1/10. 1/10, 1/10, because 2/10 makes 1/5. That's how much they had originally. So that 1/5 divided by 2 equals 1/10. And so this can definitely be a little bit tricky, especially because they have that 1/2 there. So this is a 2-point problem. So if you get all 3 correct, you get both points. And so we only had 31% of our students get this. And so we had 23% of our students get just 1 point, and that's 2 correct. We don't know which 2 were correct. My guess would be we did pretty good with that first one and that last one. If I had to guess, I would say we might have got quite a few kids stuck there with 1/2. But that doesn't match the picture. Okay? And then we've got 0. We had 45% of our students not get any points. Now, they might have gotten 1 correct. You can get 0 or 1 correct to get that 0 points. But this one is our 9th most difficult. 9th hardest on the entire test, because what we do is we take, remember, half of this, that's about 12, add it to this 31, right, we get 43% correct. So less than half. And the trick here is not so much drawing a picture because they even give you the picture. The trick is recognizing this word, this situation, turning into an equation. That's where our extra practice needs to get. It's probably not so much with the picture, but with turning it into equation and knowing when to use division, divide by 2, when to use multiplication, multiply by 1/2, and understanding that those two do ultimately represent the same thing. All right, for number 9, we are graphing on the coordinate plane, and this is standard 5.8C. And so we've got to scroll down here to see all of our options. So we'll be scrolling quite a bit. Let's see what we have here. 3 customers at a store each use a coupon for $5 off the total cost of what they are buying. Which graph could be used to represent the total cost for each customer before using the coupon X, after using coupon Y? All right, so they've defined our terms here. Okay, so I'm going to say before, and I'm going to put X. I'm going to make a little table here, get my own numbers, and then after is Y. All right, so I'm going to make a little input-output table so I can graph these points. And let me just see, I could pick random numbers, but let me see if there are numbers that they use for the x's. All right, it looks like all the way down, look, they're going to use 15, 25, 35. Just looking at my x values. Look what I got, 15, 25, 35. I got 15, 25, 35, all the way down. All right, so for the coupon, what happens if it costs $15, $25, $35? Well, there's a coupon for $5 off. So what I need to do is I need to take away $5. It's an additive relationship. It's actually, you're going to add -5 or you're going to subtract 5. So a $15 item with the $5 off, right, that's going to be $10. $25 item, take $5 off, $20. And then $35 item, take $5 off, I've got $30. These are my XY coordinates. So what I'm looking for are these ordered pairs, 1510, 2520, and then 3530. So let's see. A, and I've got 15, and I'm going to write these out over here on the side so I don't mark up everything. So what's this? This first point right here is 1515. Then I've got, they just match it, 2525. They don't even apply the coupon. And then I've got 3535. Not what I'm looking for. They didn't take the $5 off. Let's see what B's got. B has got 1510. Okay, that's good. It's got 2520. Good. And then it's got 3530. All right, that looks good. I'm thinking it's B, but let's double check to make sure I didn't miss something on C or D. Well, look at C. They just used the $5 as the Y value for all three, so it's definitely not C. Let's see what I've got here for D. I've got 1520. Oh, it looks like they added $5. Yeah, 2530. They added $5. Okay, a coupon doesn't add money, it takes money away. So it's not D either. All right, so our answer is B. Now, let's see how we did across the state of Texas. We had, and I'll put these here, A was 17%. B was our correct answer. We had 63%. All right, anything over 60, we're happy. C, 8%. No one really went for that. And then D, 11%. So we had to just apply a little bit of a rule, get that $5 off, but for the most part we did okay on this one. That's just extra practice on taking real world problem situations, creating our own XY table, that's the best way to do it, and then matching the graph. For number 10, we are dividing decimals. This is 5.3 G, and it looks like it's pretty simple here. Roberto spends, and we've got this amount here, 29.77 on 13 gallons of gas. Okay, so this is my total. This looks like we got a part-whole problem here. So 13 gallons. So what I'm going to do is I'm just going to draw 13 of these little gallons here. I'm just going to draw, rather than trying to draw all 13, I'm just going to draw that symbol right there to say there's 13 boxes. How much does each gallon of gas cost? Well, I've got equal groups. So when I have equal groups, I can divide. 29.77 divided by 13. I just need to remember my long division. So 13 does not go into 2, goes into 29 twice. Right, so that's going to be 26. Bring down one digit. Let's put our decimal up here right after that 2. Okay, so 37, 1326. I can't do 3. It is going to have to be 2 because 3 is 39. And I need 37. So let's change that back down. 26. So now I've got 117. Goodness. Well, I know that 9 times 3 is 27. So that's going to give me a 7 in the ones place, and that's what I need. All right, so $2.29 is going to be my answer. And that works. And honestly, if we wanted to estimate, right, if we wanted to say 13 rounds to 10, 29.77 rounds to 30, right? 30 divided by 10 is 3. So probably could have at least crossed out D, but I would have had to still check for A, B, or C. So my answer here is A. Now, we did fairly well on this one. 74% of our students, 74%, that's fantastic. Got that one correct. 10%, and these other ones just either guessed or made a mistake with standard algorithm. Actually, look at D right here. It's the right answer, 229. Just put the decimal in the wrong spot. But sometimes you just make those tiny mistakes, but only 8% of our students chose D. So this is our 5th easiest. So we should feel pretty happy about just using the standard algorithm to use division, even including a decimal, which sometimes can be a little tricky. So for number 11, take a look at what we've got here. We've got some stem and leaf plots, and we are looking at dot plots and stem and leaf plots. This is 5.9a. And if we look at our problem situation, we've got a number of games here, and we just need to represent this data. All right, so let's make our own stem and leaf plot here, and let's take a look at their keys. It looks like their keys are going to be just regular, meaning we've got a 2-digit number, and the stem is in the tens place, the leaf is in the ones place. All right, so if we look at our number, it looks like it ranges from 9 to 27 is my biggest one. All right, so I need my stem. Here's where it gets a little bit tricky. Okay, I'm going to do 2, 7 equals 27. But what do I do with this 9? That's where it gets a little bit tricky. So that's going to go right here. That's my single digit. But what I need something in the stem. So if I think about it, I can actually put a 0 in the tens place. A 9 is 9 ones and 0 tens. We don't normally write it like that, but you need something in that stem. I've also got the 7. Okay. And those are my only 2 single digits. All right, so let's look at my tens. Okay, and I've got an 11. So I'm just going to put a 1 right there. I've got a 17, 13, 12. So let's get them in order. 12, 13, 17. And then I notice this 18. And then on my 20s, right, I've got a 20, 24, and 27. Let's count my numbers. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, I want to make sure that My stem and leaf plot was good before we check. So let's see which one, you know, looks correct here. So what we did is, look at what we have on A. A was looking good on the ones and twos. It didn't know what to do with the 7 and the 9, so it actually made them 70 and 90. So that's not going to work. Look at my C. My C actually correctly shows the 7 and 9, but it lists every single one separately. That's the whole point of the stem and leaf plot is you can combine those into one. You can combine these into one, and you can combine these into one. So neither of these are going to work. B looks exactly like mine. That's my answer. Let's take a look at D. D that's weird. It's got 0, 2. It confused the place value between the stem and the leaf, and it just kind of, I see my 7, I see my 9, I see my 18, but it just flipped the leaf. Oh, this 2 is my 20. I see what that is. And that's my 11, that's my 12, my 13. Okay, so they just confused all those. So B is going to be my answer here. Let's see how we did. All right, so for A, B, C, and D, B is my correct answer. We had 64%, so not as high as the last one, but we're still above 60%. We had 16% choose A, 16% choose C. No one chose D. D doesn't make a whole lot of sense there. And so I do see the A and the C, not really quite sure how to work. This one is a little bit confusing, and it's a little bit disturbing. We had 32% of our students just not really sure what to do with the 7 and 9 in either location. Either of those, at least these ones and twos are correct. So we need extra opportunities to not just match stem and leaf plots, but to generate stem and leaf plots and make sure you get some single digits in there. Or if this is the case, sometimes it's would have been really difficult if it was a 3-digit number. So in that case, your stem would have been 10 and your leaf would have been 3. These are some of the oddities. We're used to 2-digit numbers, but how do we put 3-digit numbers or even 1-digit numbers in a stem and leaf plot? That's where our students will need some extra practice. Right. For number 12, you see we've got this equation editor here. And let's see what we've got. Adding and subtracting positive rational numbers. This is 5.3k. Seems pretty simple until we look at it. So we've got these miles here. 1/4, 0.75, 5/8. How many total miles? Okay, so it's basic part whole. So I've got my 3 pieces right here. 1/4, 0.75, 5/8. Now, I need to add those. Here's the problem. One of them is a decimal. 2 of them are going to be fractions. So I need to change them into the same thing. Now, if we recognize this, there's one thing that could make this problem really, really easy. Okay? So how do we visualize this? Well, look at this 0.75. This is 75 cents. And what do we know about 75 cents? Well, 75 cents could be made with 3 quarters, and each quarter is literally 4 parts. So 75 cents, or 0.75, is the same as 3 quarters. Now, I'll show you the long way. 0.75, 75 hundredths is 75 over 100. If you divide to make an equivalent fraction by 25s, you're going to get your 3/4. But look what happens if I can easily rename that as 3/4. Well, look, I've got 3/4 and 1/4. And 3/4 and 1/4 make one whole. So I've got one whole and I've got 5/8. Now, the fraction here, even if I recognize this fraction is you can make a 1 and 5/8. So let me show you how to do that. It's not the most intuitive. Watch. You have to do the whole number first. then the fraction, 5, 8. Okay, so that is one way to answer this, and it will take that as correct. But you have to hit the whole number first. Now, if I wanted to make this an improper fraction, I'm afraid of doing it like that. Well, this one whole can be renamed, right, as 8/8. So then if I take my 8/8 and my 5/8, add them together, I got 13/8. So if I wanted to, I could just make, you have to hit the fraction first, 13, then hit the denominator, 8s. That also works. Now, if I wanted to, I could also make everything a decimal. Okay, so my 0.75 is a decimal. I could recognize this as 0.25. Now, the problem with that is that 5/8. If you don't recognize that, you need to divide up. And you have to divide 3 times. Okay, so that's going to go in 6 times. It's 2. Have to keep adding zeros. That's going to be 2, 16. You need to get all the way down, 0.625. So if you wanted to, you could add all of these together, right? And you're going to get 5, 12, 6, 1.65, which makes sense. 1 and 5/8, right, is 1, and then I just said that 5/8 is 6.25. So I also could put it in like that if I wanted to. Either one of these, the 1 and 5/8, the 13/8, the 1.625. The system is set up to accept all of these as answers or any equivalent fractions. Okay, so any of these work. This was the number one hardest item on the entire test. There's no half points, it's just a 1 point problem, but you had to enter it in. It's the first hardest item. Only 22% got it correct. 78% of our students got 0 points here. So adding fractions, adding decimals might not be too difficult separately, but do our students have an opportunity to add fractions and decimals together and figure out how to uh, show the answer if it's greater than 1? So we need to be able to give our students these opportunities where they're adding fractions, decimals. We're not worried about percents yet. Percents will come up in 6th grade. But using some fractions and decimals, converting them so they're both fractions, they're both decimals, that's where our students need the extra practice. For number 13, we are looking at identifying prime and composite numbers. This is standard 5.4a, and we just have a list of numbers from 51 to 55, and we're looking for composite numbers. All right, so composite numbers are going to be those with 3 or more factors, or ways to multiply to get to that number. And then prime numbers are what we're not wanting. Those are the ones with only 2 factors, 1 and itself, right? So composite numbers, we could already say, well, 52 is composite. We can say 54 is composite because those are even numbers. And so if we were to list them out, we could say, right, we know that it's going to be 1 and 52. We also know it's going to be 2 and something because it's even. It ends with 2, 4, 6, 8, or 0. In this case, it's going to be 26, right? And then if we're thinking about our divisibility rules of 3, that means if you take the sum of the digits, and if the sum of the digits are divisible by 3, then the number itself is divisible by 3. 5 plus 2 makes 7. That's not divided by 3, so we can't do that. But we can do 4 and 13. And then there's not going to be 5s or any 6s, so I think that's about all we're going to have there. But we've got 6 different factors of 52. And if we were to look at 54, we know it's 1 and 54. We know it's 2 and something, in this case 2 and 27. Now look at my divisibility by 3. 5 plus 4 makes 9, so 3 times something is going to make 54, right? So in this case, it's going to be 18. And then, let's see, 4, it's not going to work. And 5, 6, 7, it's going to have a 6, right? 6 times 9. All right, so we've got 4 different factors there. I know that 55 has got uh, at least 1 in 55, and then it's going to be a 5 times something, 5 times 11. All right, so we've got 3 different composite numbers. The question are, what about 51 and 53? So 51, it's not even, and it's not ending with a 5 or 0. So it might be prime, but look, 5 plus 1 makes 6. 6 is divisible by 3, therefore that means 51 is divisible by 3. So 3 times something, and that's going to be 17. So that's going to be the tricky one right there. Other than that, that's the only 4 factors of 51. 53 is going to be prime. The only way to get to 53 is 1 times 53. 5 plus 3 makes 8. So it's not divisible by 3, 4, 5, maybe a 7, but 7 is going to be 49 or 56, right? 13 is going to be 13, 26, 39, 52, very close. So I have 4 composite numbers. So my correct answer here is A. And as you can guess, this one was hard. So we had only 23% of our students get this correct. Identify 4 composite numbers. We had 9% choose B. Maybe they were thinking the right thing and they identified the one prime number. That'd be very upsetting if they did all that work and they just got confused between prime and composite. We had 34% choose C, and that's because there are 2 even numbers, right? So they might have just identified the even numbers. And then we had 34%. So both C and D were chosen more than the correct answer of A. They probably thought 51 is prime because it's not a traditional number like 55 that we have a fact to. It's beyond the facts of 3 times 10 or even 3 times 12. It's 3 times 17. And so we just need to provide our students not only opportunities to play with prime and composite numbers, but look at some of our divisibility rules of 3, of 7, of 5, and just practice dividing some of these larger numbers by these small factors to see if it works. Because this is our second hardest item on the entire test. Only 23% got it correct, and more students chose C or D than chose the correct answer. So for number 14, we are looking at generating additive and multiplicative patterns. So this is 5.4c. And we've got a basic rule, x plus 4.5 equals y. All right, well, let's scroll down a little bit and let's just make our own x and y table. So I've got my x, here's my rule, plus 4.5, and then I'm going to get my y. All right, so it looks like I've only got some of my x's right here, so I'll just use these x's. I've got 1 and 2, so I'm going to 4.5. So that means my x is 1, 1.1 plus 4.5 is going to be 5.5. 2 plus 4.5 is going to be 6.5. So I should be looking at 1, comma 5.5, and then 2, comma 6.5. Let's see if I've got that. So I've got 1, I've got, no, I've got a 4.5, and then I've got a 2, and I've got a 9. Oh, it looks like they're multiplying. This is 1 times 4.5, and this is 2 times 4.5. So this is a multiplicative pattern, not an additive pattern. All right, so I've got a 0, and I already know a 1. Okay, so I already know my 1. I'm going to put my 0 there, plus 4.5. It's going to be 4.5. So I should have 0, 4.5, which that looks good. But my 1 should be 5.5, and it's not. It's 1, comma 9. Okay, so that's incorrect. I've got a 1, and I already know what my 1 is. I've got a 3, so let's add a 3. Remember, I'm adding 4.5, so that's 7.5. So my 1 should be 5.5. Okay, yes. And my 3 should be 7.5. Also, yes. That looks good. And I can tell you, both of those are going to be wrong because I needed to add 4.5. And so those are just incorrect. It looks like we actually kind of inverted the x and y. They put the y first, the x second, then you can get some of those values. So my answer here is C. Now let's see how we did across the state of Texas, right? We had only 40% of our students able to get C correct. If we're looking at A, this was our most chosen incorrect answer, 29%. And this was a basic multiplicative pattern. So we might need to help our students with practice opportunities to distinguish between additive and multiplicative. And that's something you can do. Have them plot out both to see the difference. We had 16% choose B, 15% choose D. So at this point, we're probably just, this is confusing the X and Y, probably just kind of guessing on some of these. This was actually hard. 7th hardest item on the test. They give you the rule, but unless you're creating your own X and Y table, it's going to be very hard to eyeball this. We need to help our students create their own X and Y values before trying to graph it. For number 15, we are rounding decimals. This is standard 5.2C. So Imogene is rounding a decimal to the nearest tenth. Okay, so 124.6 to the nearest tenth, which means, right, there's going to be something here in the hundredths place. Okay, now what could work in the hundredths place? Well, if this is a 4, a 3, a 2, a 1, or a 0, okay? If I make this hundredths place a 4, 3, 2, 1, or 0, then that's going to round down to 124.6. We're good. But what if I also did this? What if I did 124.5 and then I made it go up, right? 124.55 is going to round up to 124.6. And I can have any of these values here. So anything between 124.55 and then 124.64. This 55 and the 64 are going to go to that 60. So let's see, 124.06, not going to work. 124.55, yes. 124.0, no. 124.51, no. Now, I didn't think of this one, 124.61, and then we added 5. That's fine, because that 1 is still going to make that 6 just go to the tenths place of 6 tenths. So, yeah, these two are going to work. Option 2 and option 5. Now, this is a 2-point problem, and so we had, for both points, we had 41% of our students get it correct. If they only got 1 point, we don't have any data as to which one they got right, which one they got wrong. I would think this one is probably the easier one, and this one is probably the harder one, but that's just my guess. We had a full 41%. So if you're looking at it together, we're above 60%. So we're doing okay. 19% chose both incorrect, or just didn't answer the question. So this was our 14th easiest item. Not the most easy, especially because of this, right? We need to help our students when we round to the nearest number. It needs to be a range, a variety of numbers. I can round to that number. Okay, that's going to help them practice this particular skill. So next, we are looking at number 16. This is adding and subtracting fractions with models. In this case, our model is simply going to be an equation. So how do we add these three? Well, I've got twelfths, I've got fifths, I've got tenths. Please, let's not do this. And watch what happens. If I just add straight across, 1 plus 1 plus 3, 5. 12 plus 5 is 17, plus 10 is 27. This is not how fractions work. Yet 29% of our students, almost 3 out of 10, are going to add straight across. This is not how we add fractions. We need to have the same denominator, and so the easiest thing to do would just be to multiply, right, the two largest numbers, see if that's divisible by 5, but I can actually get a little bit closer. I can get to 60. Okay, so if I'm listing out my 12s, my 10s, and my 5s, we need to know our multiples. 60 is going to work. So this is what I can think of. I can think of 1/12 times something. It's going to give me 60, but that's the real work. So try to figure out what is my least common multiple going to be. Once I see 60, I know 10 and 5 go into 60. All right, so that's going to be 5 over 5, because you multiply by the same numerator and denominator, so 1/12 equal 5/60. We're going to multiply this by 12s to get to 12/60, and then 3/10. Multiply by 6 to get to 18/60. So now I've got 5/60 plus 12/60. Now I've got the same denominator. I can add straight across. 5 and 12 is 17. 17 and 18 is 35/60. That is our answer, and that is D. So we already said 29% of our students chose A, right? We had 17% of our students choose B. We also had, let's see, we had 4% of our students, not much, choose this C, right? And then we had, what do we have? We had 50% of our students. So half of our students choose D. So that's not horrible. Now, how did we get some of these answers? Well, if we're looking at A, we just simply added the numerators and denominators, like we said. And B, right, we just added the numerators. 1 plus 1 plus 3 makes 5. And then the largest listed denominator is 12. Same thing with C. 1 plus 1 plus 3 makes 5. And then the smallest denominator. And then obviously our correct answer there was going to be D, 35/60. And so for this item, right, this was the 12th hardest, 12th most difficult. So not the easiest, but definitely not the hardest as well. And so looking at our next item, at number 17. We are dividing whole numbers and unit fractions. This is standard 5.3L. And we've got Mary here with 3 pies. So I'm just going to draw 3 pies. If it says we got 3 pies, I can make 3 circular pies. Each pie is cut into equal slices. We got fractions. Each slice is 1/6. All right, so the easiest way to make a 6 is to cut each one in half. Then what you do is you kind of make a fat X. All right, so there we go. I've got 6ths. All right, so there we go. I've got my 6ths. How many slices does Mary have? Well, I can just count like this if I need to. I've got 6, 12, 18, right? Now, how do we, that was a real quick representation with circles. How do we represent this with an equation? Well, I've got 3, and I'm dividing it into sixths, right? So dividing into sixths, which is the same as multiplying by its reciprocal, which is 6 over 1, which is just 6. So that's going to be 18. But the visual, you don't even need the equation or the expression. The visual really helps. We had 60% of our students do this, so that was pretty decent. We had 20% of our students, 1 out of 5, choose this, and this is just if you take your 3 and then you multiply it by 1/6, you're going to get 3/6. So they knew they had to multiply or divide, they just didn't know which one. We had 16% of our students choose C, and then they just thought 3 might have been 3/3, multiplied by 1/6. That's kind of a weird way to get it. And then we've got 4% of our students choosing this, and that's just 3 plus 6. So there's a few different ways to get some of these answers, but 60% of our students choosing 5.30, not horrible. This is our 16th easiest, so kind of close to the middle of the pack here in regards to difficulty for our students. Let's see, we need to make sure we answer the question. There we go. For number 18, we are looking at simplifying expressions and order of operations. This is standard 5.4F. So I've got this expression here. I need to think of my order of operations. Please excuse my dear Aunt Sally. I always write my multiplication and division on the same line, addition and subtraction on the same line because they're equal inverse operations. I can do either one left or right. So when I've got these brackets here, those are like my super parentheses. I need to take care of everything within these brackets before I even think about that 2 times. So what I'm going to do is I'm going to rewrite this here. 30 minus 20 divided by 5 times 2. So this is what's inside my brackets. I need to completely bring that to a single term before I even think about that 2 times. So within this, I've got my parentheses. So 5 times 2 is 10. So I've got 30 minus 20 divided by 10. Now I've got a subtraction. I've got division. Division comes first. So 20 divided by 10 is 2. So I've got 30 minus 2. Now I can do 28. Now this is all within the bracket. So now I get to bring my 2 times 28 is 56. So I've got my answer there of D. And for that particular answer, we had 52%. So not much more than half of our students were able to get this correct. We had 21% of our students choose 8. And then this is just if we were to go straight from left to right without thinking of these parentheses, right? You could have done this, right? And then we would have had this 16, 17%. And this is just performing all operations left to right without even thinking of parentheses or brackets. And then we've got 44, which is 10%. At this point, it's kind of statistical noise. You could do this if you use PEMDAS, but you ignore the parentheses. So 52%, this is as complex as we're going to get in the 5th grade. We need to provide multiple opportunities for our students to practice this as it is 13th hardest. So definitely landed on a little bit more of the hard side than the easy side for our students. For number 19, we are looking at the attributes of the coordinate plane. This is standard 5.8a, and we simply need to match some of our terms here. And so we have the vertical line, number line on a coordinate grid, the first number in an ordered pair of numbers, and then the point where the horizontal axis meets or intersects the vertical axis. So if we're thinking of a coordinate grid, and in 5th grade we're just looking at quadrant 1, so we've got some positive numbers going this way, some positive numbers going this way. All right, so let's look at our descriptions once again. The vertical number line on a coordinate grid. So this one right here that I drew, we would hope that our students would recognize this, right, as the y-axis. So the x-axis is what goes side to side horizontally, and the y-axis is what vertically goes up and down. So we would want to put the vertical number line as the y-axis. Now, what do we call the first number in an ordered pair of numbers? Okay, so let's say I plot this point right here, right? And x comes first. So we always put our x value first. and then y comes second alphabetically, so we put our y value second. So in this case, we would plot this as 3, comma 4. But look at that first number. That first number is our x value, or our x coordinate, because it's on the x-axis. It's over 3 spaces, whereas the second coordinate, or the second value, is up 4 spaces. So we would need to recognize that this first number is our x coordinate. And then finally, where do these two meet? Well, they meet at 0, 0, and 0, 0's got a very special place in the coordinate plane. It is called the origin because it's where each of the axes originate, at least in regards to the positive values. When we get into 6th grade, we're going to notice that these go in all 4 directions. So the origin is actually the center. So we could call this the origin, and that is how we get full credit on this 2-point problem. This was a very difficult item because there's not really any visual. It's just a lot of verbal descriptions. So if you got all 3 correct, you got 2 points. And so let's say this is 3 correct. Only 22% were able to get all 3 correct. 1 point is going to be 2 out of the 3 correct. And we had only 19%. So you put that together, that's about 32%. That is low. 0 points. Now, we don't know whether they got 0 correct. They could possibly get 1 correct, but 1 out of 3 correct doesn't get you any points. Take a look at this. 59%, almost 60% got 0 or 1 correct. This made this tied for the third most difficult item on the test. And it's because we spend so much time in 5th grade actually plotting points. We might not spend as much time on the supporting standard describing the attributes. And it's all about vocabulary, and it's all words. So obviously we need to spend time with our students describing the coordinate plane with words, having them write about it. It could be a practice SCR or even ECR if we wanted them to do something a little bit more extended with that with our students and not just plot the points. They need to be able to describe its attributes. So for number 20, we are looking at decimal division with models. This is standard 5.3F. And we've got some visuals here if we scroll down. So let's see what we're looking at. Person has $120 or $1.20. It's 120 pennies. 4 equal stacks. Okay, so $1.20. So we see we've got our hundreds grids, right? So if I wanted to do hundreds grids, I could just shade in this full thing right here, right? That's going to be 100. And if I just did the first 2 right here, that's my 20. Okay? And then I did my 1.2, 120 pennies divided by 4 equals 30. Okay, so that makes sense. So I would need 30, and I could do that a few different ways, right? I could do 30, 30, 30, 30. That would be one way that I could recognize, that I could represent this. Or, I guess if you wanted to, you could just go across, right? You could just go like this, 30, 30, 30, 30. Either way, you're splitting up the amount that's shaded in into 4 equal sections to get 30 cents or 0.30 in each. So take a look at this. Each of our representations has the 120 pennies, but what is going on with this A right here? That's only sets of, it looks like 24, and it's got this fifth section right here that's not even used. So that one is not going to work. This one, yeah, this one looks like what I did right here. It's got the 30, 30, 30, 30. So B looks good. I've got 3 sections here of, it looks like 36. So first off, that's only into 3 groups, not 4 groups. And then secondly, what is this final group right here? And then this one looks kind of close, D, but look, it's only three groups, and it's 40, 40, 40. So that's 40, 40, 40. So this is probably the closest. 120 divided by 3 equals 40 cents each. So that's close, but that's not quite what we need. It is going to be that B there. Now let's see how we did across the state of Texas. Our correct answer, B, is right here. So let's go ahead and just put it right there. B, we had 59% of our students getting it right. We had the most incorrect choices on A. We had 21%. So they saw the four groups. They just ignored that bottom section for whatever reason. We only had 9% choose C and only 10% choose D. So I didn't really see as many students choose that D as I thought we might have. It really was that A that kind of messed us up for whatever reason. They got the four groups and they just completely ignored that final group. So this is a standard 5.3F, and we're not necessarily even dividing with decimals because look, they give you the actual equation right here. They give you the answer. It's all about how you represent it. There's multiple ways to represent this. So our students need lots of practice. This is right in the middle, but it actually tends to be slightly easier than harder. It's the 17th easiest item on the test. So for number 21, we've got this inline choice here, and it's about income and payments. So this is standard. Let's see what we've got here. 5.10b, and it's just a lot of words here. Rose's salary is 450. Her take-home pay is less. It's 385. So she makes 450 a week, but she actually gets a paycheck for 385. So she's missing some money. Now, Rose's take-home pay is her. Let's see what our options are. Net income and gross income. Right? So this is just, do we know our vocabulary? This is a personal financial literacy. So if students haven't spent time with this, then it's really going to be difficult for them to just guess. So her take-home pay, right, is going to be her net income. So your net income is what you actually get on your paycheck. So your gross income, don't know why it's called gross, but that's just the term they use. The gross income is your salary, what you should earn before deductions. Now, your deductions can be taxes, can be Medicare, can be insurance, can be a savings plan. So even though she earns 450 a week, she actually only gets 385 because the other $65 goes towards deductions. So her take-home pay is her net income because taxes and deductions were, let's see what we have here, added or subtracted from her net or gross. Well, we already talked about that. We said they were subtracted, but they were from her gross. So her taxes and deductions were subtracted from her gross income. That made her net income. So we need to think about it like this. So we've got our gross income, right? It's kind of like this big circle, and then inside that you got your net income. And then what you lose are going to be your taxes and your deductions. So your net is always going to be smaller than your gross. So this was difficult for students. 2-point problem. We only had 29% of our students get both of those correct. We had 47% get one correct. Most likely they got this first one correct, and really it's just because you had a 50-50 chance. So even if we got it right, we don't know whether or not you really understood it. And we had 24% of our students get nothing correct. And so we're looking at about 53%-ish scoring correct, and that's about the 14th most difficult, or at least tied for the 14th most difficult. This is all about vocabulary, all about talking to students about personal financial literacy. Make sure they understand these terms: net income and gross income. For number 22, we are estimating with the four operations. This is standard 5.3a. And we've got a jar containing 192 and 6/10 milliliters, a jar containing 705 and 2/10 milliliters approximately. So that's what lets us know that we can estimate how many more. Okay, so we're going to compare these two. So let's just say 192, right, is kind of between 100 and 200. I'm just going to go to the hundreds place. Look at that 192. 192.6 is going to be really close. So I'm just going to call that 200. And then I've got my 705. Could do the same thing. It's between 700 and 800. Look how close that is. That's 705.2. So that's really just about 700. So about how much more is my 700 than my 200? Well, if I'm comparing these, I'm looking to see what's the missing. The missing piece is about 500. So it's about 500 milliliters. And basically, we did pretty well on this as a state. C is the correct answer. We had 67%, so we're feeling pretty good about that. 2 out of every 3 kids got this correct. And then the other answers were just kind of a smattering of incorrect guesses. Now, here's the sad thing is the students that got this 900. Now, that's the smallest number, but that's what happens if you add the two. And so we've got some students that might have estimated correctly, but they used the wrong operation. These other ones, 800, 600, that's just where we're using the wrong rounding estimate. And so this is our tied for our 8th easiest, not that difficult for our students. And so good for them. We're feeling happy about estimating to solve operational problems. For 23, it is multiplying decimals, and there's not much to it. It's just multiplying decimals, standard 5.3e, and they just want the answer. They're not even going to try to make you guess what operation we're supposed to do. 1.5 times 1.12. All right, so let's just multiply. Let's multiply 112 by 1.5. We're going to ignore the decimals for now. We're going to pretend it's 112 times 15. We're going to grab the decimals at the end. So standard algorithm here. 5 times 2 is 10. 5 times 1 is 5. Add that 1 is 6. And that's a 5. And then now we can just write 112 underneath because it's going to be multiplied by 1. I don't even need to do any regrouping when I'm adding here. Now, let's bring our decimals. I've got 1, 2, 3 digits behind the decimal. In my factor, so I need 1, 2, 3 digits behind the decimal. And my product's 1 and 680 thousandths. Right, we can drop that 0. We don't need it. So it's going to be 1.68, or 1 and 68 hundredths. And so my answer here is A. Now, we did decently. 54% of our students were able to get A. 8% chose B. 11% chose C. Now look at D. This isn't a problem that really tests your ability to multiply a 3-digit times 2-digit. This is something that's going to test your ability to find the decimals. Because look, 16.8 and 1.68, same 3 digits. They just put the decimal in the wrong spot. We could have used estimation on this, okay? So 1.12, if I were to round this, it's basically 1. So I don't have to round 1.5, okay? Let's just keep 1.5. It's right in the middle. I don't want to round it all the way up to 2. I don't want to round it all the way down to 1. So what is 1 times 1.5? Well, it's going to be 1.5. So I need an answer around 1.5. And what is around 1.5? Well, that is around 1.5, 1 and 68 hundredths. But 16 and 8/10 is nowhere close. So this is really testing students' ability to find the correct spot for the decimal point once we are done multiplying. This is our 16th hardest item on the test. And the practice here for students is definitely about where to put the decimals, not necessarily how to perform the calculation. Number 24, we've got area, perimeter, and volume. This is 5.4H. And we have the perimeter of a rectangular tablecloth is 320. The width, I've seen a problem like this on the 3rd grade and the 4th grade test. There's no picture, so let's just draw a picture. Okay, so rectangular tablecloth. So here's my rectangular tablecloth. All right, what do I know about this rectangular tablecloth? The perimeter equals 320. Okay, now I can also look to see, do I have anything on my reference material? Perimeter is 2L plus 2W. Okay, so I know that P equals 2L plus 2W. Now I can make this a strip diagram. Okay, so what I'm going to do is I'm going to say, here's my perimeter, 320. And it's going to be 2 lengths and 2 widths. That's 2L plus 2W, right? If I add the length plus width, what do I have? I've got the perimeter. The width is 70. Okay, so I'll just make this one 70. So if that's 70, that's 70. So if the width is 70, I'm going to replace this with the 70, replace this with a 70. But what do I have right here? I've got 140. So if I want to rewrite this, I've got 320 is my entire perimeter. And I could do it like this. I can say, well, this is 140. That's my double the width. And then I've got 2 lengths. Well, if that's 140, what does this have to be? I'm going to need to subtract my 320 and my 140. And that is going to give me 180. Now, the answer is not 180. Don't choose 180. That's going to mess kids up here. Okay? I need to take that 180, I need to split it in half. So what is half of 180? Well, we can divide by 2, or we can just say, well, that's about 90 and 90, because 99 make 18, so 90 and 90 make 180. So I think this is going to be 90 and 90. Now, how can I double check this? Well, let's add all of these up. Let's see if 70 and 70 and 90 and 90 get us to where we need to go. So we got 7 and 7 is 14, add the 9 is 23, add the 9 is 32, so I get back to 320. So my length, my missing number, is my 90. So my answer here is C. Now, this was a difficult one for our students. Let's see how we did. 90 was our correct answer, 32%. So that is extremely low. But look at our most popular answer was A. 48%. Almost half of our students got A. How are we going to get A? You take your two numbers and you simply subtract. That is not how we find perimeter. So step 1, draw a picture. If we draw a picture and try to label it, we realize there are 4 sides. They've only given us the perimeter and one side. Now, once you have 170, you know the other side is also 70, but now we're still missing 2 sides. So this is not anywhere close to what we need to be doing with our students to help solve this problem. We don't just take 2 numbers and subtract, draw a representation first, and you notice I went from a representation to a strip diagram to represent how many missing sides there are. There are 4 sides on a rectangle, which means I need 4 numbers, 2 sets of 2 numbers. B, we had that 180. Not many people chose it because if you got this far, then you're probably going to take that next step. Not many students are going to go all the way here and think, oh, the answer is 180. They probably know what's going on. And then 125, only 5%. You have to really, that's just statistical noise. You would subtract the 3 20 minus 70, and then divide that by 2. That's the 250 divided by 2. This is very, very difficult. This is tied for our third hardest. Like I said, I've seen this on a third grade test and a fourth grade test. Until we can figure this out, I think we're going to keep seeing this on STAAR tests. Basic setup is they give you the perimeter and one of the side lengths. You need to find the other side length. Our students can do it if we get them to draw a picture and a strip diagram to represent how many side lengths we're dealing with. Then they can visualize what they're actually solving for. For number 25, we are looking at dividing whole numbers and unit fractions. This is standard 5.3L. And we've got a drag and drop here. So we've got two different spaces that we need to use, that we need to fill in. And if we look here, we'll notice that the operations can be filled in any location, and the fractions can be filled in any location. So we're not restricted as to where we're going to use them, though it would make sense that we're going to use an operation between the 3 and the 1/4. So let's read. Let's see what we have here. Tricia runs around a track. The distance of one lap around the track is 1/4 of a mile. She runs a total of 3 miles. Okay, so I want to show what she's doing here with a strip diagram. Okay, so I've got my total here, and they give you the total, so 3 miles. Then each time she runs around, it's 1/4. So here is my question. How many 1/4s does it take to make the 3? And so when we do that, normally what we're doing is we are dividing. But let me show you with a number line, just so you can see exactly what our answer is, because we need that as well. And so what I'm going to do is I'm going to say, here are my miles. 1, 2, 3. And each time she runs, it's 1/4 of a mile. So what I'm going to do is I'm going to cut each of these in half, cut each half in half, then I've got fourths. All right, so now what I've done is I've got each of these 1/4s, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what I did was I took my 3, I divided it into sections. Rather dividing it by a whole number, I divided it by a fraction, and there ended up being 12 sections. Because one way to double check that is when you divide by 1/4, that's the same as multiplying by the reciprocal. So you end up flipping the 4 upside down, you change the division to multiplication. Either way, you get 12. And so that is going to be our answer. 3 divided by 1/4 equals 12. As you can probably guess, this was a difficult item. To get full credit, you needed to get both of those blanks correct, and we only had 24% of our students get that right, and only 27% got partial credit there. So we're looking at about 38% correct overall. 49%, almost half, got 0 points. This one is difficult, and there's not much more to do about this than to continue to have our students work with these problem situations and draw some type of representation, either a strip diagram, either a number line, something to not only represent the problem, but to give them a clue as to whether that representation is pointing them towards division or multiplication, because that's where it gets tricky, is understanding the correct operation that we need in order to solve the problem. And in this case, we needed to both represent it and to solve it. For number 26, we are recognizing volume. This is standard 5.6a. And so we have this rectangular prism, and it's going to be completely filled with cubes. How many unit cubes are needed to fill the prism? Well, this is going to go back to our basic understanding of volume. And the volume of a rectangular prism is either base times height or length times width times height. And so we can use this length times width times height because they actually give us the three different uh, dimensions here. And so what I want to do is I want to see if I can draw, right? So if we get 2 across, we've got 4 back, like this, and then we've got 2 high. Okay, so what we're going to do is we're going to kind of do the same thing, and it's going to go back like this, and it's going to do that same thing. And obviously, it gets very difficult to draw like this, but if you can kind of visualize that, that's really what we're doing here, is we are cutting this into all those different pieces, and all obviously the lines they kind of get messed up. But there's 2 going across, there's 4 going back, there's 2 going up. 2 is our height, so really we're just going to substitute in the 2, the 4, and the 2, and 2 times 4 is 8, times 2 equals 16 unit cubes. And so, yeah, that's going to be our answer. Pretty straightforward here. And so we had 10% of our students get A. We had 7% choose B, 6% choose C. Almost at this point, statistical noise. There's not really a distractor that was messing this up. If you got 8, I mean, you added 2 plus 4 plus 2, but not a lot of students did that. 76% got 16. That's great. This is our 4th easiest item on the test. We would expect them, with all the work they would do in 5th grade, to introduce volume for the first time. We would expect our students to do well on this, and they did. So 27, we are solving data problems. This is 5.9C, and we've got a dot plot. So let's take a look at this dot plot. It records the number of hours that are practiced each week. What is the difference between the greatest and the least number of hours practiced? Okay, so here's the trick. You see this 1/2? That is the smallest number on the dot plot, but there's no dots in front of it. If I were to look at my data, right, there'd be 2 1s, 4 1.5s, 2 2s, so on and so forth. So the largest is going to be this 4.5 because there's a dot on it. The smallest is going to be the 1 because there's a dot on it. No one practiced half hour, even though that's the lowest number on our scale. So that's going to be the trick on this one. So we've got 3.5, so our answer here is C. And on this one, let's see how we did. We had 53% get this, so not quite at that 60 that we're hoping to get. And yeah, we got tripped up because 22% of our students, the most chosen incorrect answer, chose A, which is 4.5 minus 1/2. So this is where we need to spend a little bit of extra time talking to our students about, just because it's on the graph doesn't mean it's represented in the data set. There's no dots on top of it. That's blank. That means no one is choosing that. Because sometimes we'll have a blank in the middle. We might have this missing. And we know that that's not being represented. It's just when it's at the front or the back end and they're asking us for range. That's where it gets difficult. So we had 14% choose this, right? So this, now what we're doing is we're at least reading it correctly, but we're adding the 2. And then we've got 11% choosing D, and this is where we are subtracting the number of hours of the least, right? Right here by that lowest number. That's one way to get that 1, or no, here we go. You can get it by doing the least 1/2 minus the most right here of 1.5. It's kind of a hard way to get this, but 11% of our students did, which means a lot of them just guessed. This was our 14th most difficult, and tied. And so even though reading a dot plot is not new for students, we start that in 3rd grade, and this is a fairly straightforward item. We did have to deal with recognizing range, subtracting mixed numbers and whole numbers, and then obviously we had that big trick right there as to understanding that 1/2 is not necessarily represented in the data set. For number 28, we've got a drag and drop here, and so we have this equation that is being modeled for us. We're looking at standard 5.3i, multiplying whole numbers and fractions with models. So we've got this key here. So it looks like if this is my one whole, I've got two of the same thing, but they're not completely filled in. I got 1, 2, 3, 4, 5 out of 8, and I've got 5 out of 8. So what I could do is I could just say, now here's the thing, we have to ignore the key. Once we've used it, we need to ignore it and not include it in our operation. I could say 5/8 plus 5/8, but I need to use multiplication. So I need to think of multiplication as repeated addition, which means I've got 5/8 times 2, or I've got 2 sets of 5/8, right? And then what that means, how many 8s do I have altogether? Well, 5 and 5 is going to make 10, because 5 times 2 makes 10. So 5/8 times 2 equals 10/8. And this is a 2-point problem, so we needed to get all 3 correct in order to get 2 points. And we had 64% of our students get both points. That's fantastic. We needed to get 2 out of the 3 correct to get 1 point. We had 8% of our students get this. So you either knew it or you didn't. So altogether, we're looking at about 68% correct. So that's well above that 60% threshold. We're pretty happy with that. 28% of our students got 0 correct. They either got 1 or none correct to get the 0 points. So overall, this was very much on the easy side. This is our 7th easiest item on the test. Pretty straightforward, especially with that new concept in 5th grade of multiplying fractions. So kudos to the students of the state of Texas. For number 29, we are classifying two-dimensional shapes. When you see a Venn diagram, you should be thinking, oh, we're classifying 2D shapes, because it's called for in the standard, which is 5.5a. So we need a shape that does not belong in this blank spot. It's in group 1, but not group 2. So I need a shape that's going to end up over here. So that's a little bit of a trick. Bet you that's going to mess up some of our students. So a square. So what do we know? At least one pair of congruent sides. So I can put a square definitely in group 1, and at least one pair of parallel sides. Yes, so here's my square. So I've got congruent sides here. I've got parallel sides right here. All right, so it can go in 1 and 2, which means my square is going to go right there in the middle. An isosceles triangle. All right, so I don't know whether it's a right isosceles, a cute isosceles. We'll draw a right isosceles like this. All right, so at least one pair of congruent sides. Yes, these two are congruent. It does not have any parallel sides, but it can have perpendicular sides. So this one, I'll put down here, can definitely go right there. All right, so that goes in just group 1. Trapezoid. I can have a right trapezoid. I'll just draw a regular trapezoid. Okay, so at least one pair of congruent sides. This one does, but you see this right trapezoid right here? That one doesn't. So I'm not sure about this one. I'm going to say question mark. And at least one pair of parallel sides. Yes, you've got at least one pair of parallel sides. So I can draw it in both spots. It definitely belongs in group 2 and sometimes in group 1, sometimes not. So I'm going to draw a trapezoid uh, over here if it's a right trapezoid, and I'm going to draw it right here if it's just what we would consider a regular trapezoid. Either way, it's not in group 1, so we're good. And then a scalene triangle has no congruent sides. They're kind of hard to draw. So definitely not group 1, and it's got no parallel sides. It's just out here, out in the middle of nowhere. All right, so we do have this isosceles triangle that is going to be our answer because it is in group 1 but not in group 2, and we had 49% of our students able to get this. Obviously the trick here is there's no pictures, just words, so students should be able to draw their own representation of these shapes. We had 10% of our students choose the square. As we said, the square belonged in the middle, which is normally what we're solving for, so we've got to read closely. That trapezoid, we had 20% of our students choose this. Scaling triangle, 22%. Not sure why we do that, but we might not be too familiar with that word, scaling. And we know that it doesn't have any parallel sides, but we might not remember the term congruent or might not know what scaling is. It doesn't belong in either group. So this was definitely on the harder side. This was tied for our 10th most difficult item on the test. And we need practice not only finding something that belongs not in the middle, but in just one of the circles or portions of the circles, but also drawing visualizations of these shapes when they are not provided for you. For number 30, Layla is feeding her dog, and this problem is going to have us divide decimals. We see that decimal 97.5. When we're dividing decimals, we are looking at standard 5.3 G. So she feeds a total. Look at that. When we've got the total, that means we can put a strip diagram here, and we can say, look, we've got the total. So we've got a part to whole here. And so over a period of 30 days, the same amount every day. So what I can do is I can draw 30 boxes here. There's 30 parts. What I'm going to do is I'm just going to do this with 30. So you get that there are 30 different boxes here. So how much does she feed each day? Well, I just need to divide 97.5 by 30. And if I wanted to round, right, 97.5 is 100. So 30, 60, 90, 120. So it's going to be right around there. So it's going to be 3 something. 3 something is going to be my guess. And that means I can eliminate C because that's not going to work. So there we go. So 30 goes into 97 3 times. We need to bring our decimal up. You just put it straight up. That's 90. And that's going to be 75. 30, 60 goes in twice. And now I need 150. I'm just going to add that 0. Keep going. We don't need a remainder. 30, 60, 90, 120, 150. So 3.25 or 3 1/4. So our answer here is going to be B. Now, how did we do? We had 55% of our students get this correct, so not quite at the 60% threshold. Look at this. We had 23% of our students choose 3.2. Very interesting. Because what that is that's when you get this and you don't have that extra 0. You've got a remainder of 15, but you're not sure what to do with it. So if you just stopped and didn't add the 0, you'd get that 3.2. Obviously, the 32.5, they misplaced the decimal point. We had 18% of our students get this. Only 4% of our students choose that, which is just statistical noise. They just didn't use the algorithm correctly. But that means that 23% of our students didn't know what to do when they had a remainder and no digits left, so they just stopped. Interesting. Something we can work with our students on, and we've got our 17th most difficult item on the test here at number 30. For number 31, we are comparing and ordering decimals. This is standard 5.2b, and we've got a list of numbers, and we simply need to find which comparison is true. And you notice they are all listed with the symbols going this way, which means greater than, right? So this is greater than, this is greater than, this is greater than. So without it telling us, we need to know that we need to have from greatest to least. Since each number to the right is supposed to be smaller than the number on the left, so we need greatest to least. So let's make a place value chart, and it looks like we go from the tens place to the thousandths. All right, so I'm going to draw a nice thick line right here. That's going to be my decimal. And I've got my, I'm just going to put the place value, tens, ones, tenths, hundredths, and then thousandths. And as always, we're going to put some extra zeros in after the decimal just to make things a little bit easier. So 42.5, use the decimal places, kind of my marker, it's going to be 42 and 5 tenths. Let's go ahead and make 500 thousandths. Now, this one's a little bit tricky because there's no decimal, so we need to be able to put 42 right there. That's just a regular number. I could still put 0.000 afterwards. I've got 42 and 63 hundredths, so I can add a 0. And I can do 41 and 172,000. So they're all going to the thousandths place, and we need greatest. All right, so greatest, it's not going to be this. So this one's going to be last. This 41, 172 is going to be last because that's got a 41 rather than 42. So I can go ahead and put that at the end. The rest are 42, so those will kind of get ignored. I'm now looking at my 10th place, but look, I've got a 6, a 0, and a 5. So I'm going to use this 6 next. So 42 and 63 hundredths is greater than. Now I've got the 42 and 5 tenths is greater than plain old 42. And then my 41 is that's last. So that is our order comparison from greatest to least here. And so how do we do across the state of Texas? Well, the correct answer here, as you can see, it matches what we did here, is D. And decent, 65%. So we're happy about that. Now here's what's interesting looking at our incorrect answer choices. Look at 13% of our students chose A. Now A might not seem to make any type of sense. They're all jumbled up, but look closely. Look at the number of digits included in this number. 5 digits. This is 4 digits. This is 3 digits. This is 2 digits. So that's more than just statistical noise. There are some students that literally looked at the number of digits and said, oh, that's the order. So obviously we've got some misconceptions with those students. We need to help them work through. B is 8%, so that is very close to statistical noise. They just compared the rightmost digit in each number. Right, so 5 is bigger than 3, but then the two twos are the same, so I don't know how they chose there. Now this one is interesting. This is the exact correct answer, but they just confused the symbols. Same answer, just reversed. So there could have been some students that did all that work and still got confused with the greater than or less than symbol. So this is an interesting setup to where it doesn't tell you least to greatest, greatest to least. You got to figure that out on your own, and then you've got to figure out how to use this symbol. So we need to make sure we give our students plenty of practice problems with this setup here. But this is a little bit on the easier side, 11th easiest in the test. For number 32, we are generating additive and multiplicative patterns. This is 5.4c, and as you can see here, this is going to be a drag and drop here. So here's our basic equation, y equals 6x. So y equals 6x. So what I want to do here is I want to use this table here since they've already given it to me. Y equals 6x, which means I can flip it around, right? I can say 6x equals y. right? So that means I could uh, take each term, flip it around so it kind of faces the same direction as my table here. Because now what I can do is I can plug my 6 in to that x right there. So this is really saying 6 times x or 6 times 6. So 6 times 6 equals my y, so that needs to be 36. This is equals 60, so 6 times, I'm going to put x here, equals 60. 6 times what makes 60? Well, that's a basic fact. So 6 times 10 makes 60. So let's grab the 36. Let's grab the 10 and keep going. Same thing with this. Equals 72. So 6 times what is going to make 72? That's a little bit beyond basic facts, but a lot of our students still know this is 12. And then this is going to be 6 times 20 equals what? And 6 times 20 is going to be 120. So I need that 12, and I need that 120. 12 and 120. All right, so now I've got all 4 answers correctly chosen there. And so how did we do? This is a 2-point problem. So in order to get both points, you need to get all 4 items correct. And let's put that here. We had, look at this, 63% of our students get all 4 correct. That's fantastic. We should be very pleased with that. This is going to be 2 or 3 correct to get that 1 point, and 17%. Right, so you kind of take half of that. Half of that is about 9. It's about 72%. So good job, students. And 19%, obviously we'd rather that be 0, but overall, when you're looking at 72% completion, we're doing pretty good here. So that's 0 or 1 correct. So this is definitely on the easier side. This is actually the 6th easiest item on the test, and it was drag and drop. So that made it a little bit more difficult than just multiple choice, but kudos to our students for their work with generating additive and multiplicative patterns. 33, we are graphing on the coordinate plane. This is 5.8c, and we need to look at this table of input and output values that is shown and find the graph that matches that. 5.8c. All right, so let's see what I've got here. Well, the easiest way to do this is let me just take my value here, or my table of values, and let me just transfer it down here so I don't have to scroll. And this is something we might want to talk to our students about. If the scrolling is getting to be too much, write it down on the scratch paper, use the tool to write on the screen if they need to, so they don't have to scroll up and down. Okay, so I just want to then create a table of values for each of these, okay? So I'll just see which one matches. All right, so this first one, x of 2, y of 7. And then I've got an x of 4, y of 8. And an x of 9, y of 5. It looks like exactly flipped. You notice they flipped the x and the y values, which probably going to mess some students up, but they just flipped those right there. Let's check B. So I've got, this first one is x of 4, y of 8. Okay, that's what the last one did. I get an x of 7, y of 2. That's correct at least. And then x of 9, y of 5. They flipped these two. So one is correct, and they flipped the other one. So neither of those are working for me. Let's check C. X and y. All right, x of 5, y of 9. That works. Next is x of 7, y of 2. That works. And then x of 8, y of 4. Hey, we got all 3. So that works up there. Let's just verify that this one doesn't work. I get x of 2, y of 7. Yeah, they flipped them. X of 8, y of 4. That one's correct. And x of 9, y of 5. They flipped those one. So kind of like what we did over here on B, they just had another one that was correct, a different one that was correct. All right, so our answer here is C. And for the most part, our students actually did okay on this one. We had 77% of our students, let me put that here, get this correct. So that's fantastic. 10% chose A. We had 7% choose B. And we had 5% choose D. So even all the way at the very back of the test, they did a wonderful job. Third easiest item on the test. Anytime you can get a graphing problem like this where you're just selecting multiple choice rather than actually having to create the graph, students are typically going to be doing okay. All right, final item. Number 34. We are looking at decimal multiplication with area models. This is 5.3D. And we've got this hundredths model represents one whole. Okay, so each of these are going to be less than a whole, because if this equals one whole, then nothing else is as shaded as much. Okay, so these area models, unless you've really practiced this, can sometimes be a little bit difficult for students. Okay, so let's see what we're dealing with here. So what we're dealing with here is, take a look at how many tenths we've got. These are hundredths, but they're full columns, so I'll just call them tenths. I've got 1, 2, 3, 4, 5, 6, 7. 0.7 times, how many do I have here? 0.3. And that equals, and if you count, how many squares do you have? You got 21. And I'm looking for 7 tenths times 7 tenths equals 49 hundredths. All right, so it's not A. So this is going to be 8 tenths times 1, 2, 3, 4, 5, 6. So 8 tenths times 6 tenths equals very close to what we wanted. That's 48 hundredths. But I'm looking for 49. Now, you'll see the symmetry here. I've got, this is 7 tenths. This is 7 tenths. So that could have been one clue, right? If both of your factors are 0.7, it should look like there's some symmetry in the image, and that's the only one that actually has that. And if you counted these, what you're going to get is 49 hundredths. So that is our correct answer. And then this is 3, and this is 9. So that's not going to get what we need to. That's 27 hundredths right there. So our correct answer here is C. And we had 67% of our students get this correct, so not bad. A, we had 16%. This is our most chosen incorrect answer, right? The only trick here is I've got 7 columns here, right? But look at what I have right here. I've got 7 unshaded. So we might have had some students kind of get tripped up. There were 7 shaded and 7 unshaded. And so that's how they might have gotten A. B is just 6 and 8, so it's kind of close to statistical noise, and D definitely is statistical noise. So overall, this was tied for our 8th easiest item on the test. There are a few different ways that we can have our students represent decimal multiplication with area models in regards to the orientation. And so we just need to give our students plenty of practice so they are fully prepared to answer these types of questions.